Thanks everyone for tuning in to the Angler Survey Committee April webinar. We've got 3 talks lined up. Our data management subcommittee is going to give a essentially a best practices talk on how to build and maintain databases for managing fisheries data. And then after that, we're gonna Josh McCormick with Idaho Department of Fish and Game is going to present some of the research he's been doing using state-based models to estimate effort. And then I'm going to finish it up with some research that I had been leading as a biologist with Texas Parks and Wildlife, and have this project is still maintain a large part of as we're working to submit this manuscript, working to assess the overfishing potential of live imaging sonar relative to crappie fisheries. All right, so with that, I am gonna stop sharing my screen and turn it over to the data management team, and yeah, it's all yours.
Great, thanks, Dave. Can you just give me a thumbs up if you're seeing the PowerPoint? Okay, hop in at any time. I don't always have a great connection here, so if I start breaking up or something, let me know, and I'll turn off my camera, and that might help. So today, go ahead.
Hey Nick,
Dave.
sorry, did somebody raise their hand? I just wanted to give them the opportunity if they wanted to say something before you started. I don't know if that might have been an accident. All right, well, sorry about that, Nick.
No problem at all. If anyone has anything, feel free to jump in or put something in the chat. We're going to go ahead and try to leave a chunk of time at the end for some questions and discussions as well. So if folks have, questions for us or have had their own experiences working on this kind of stuff that they'd like to share from the group, we'd love to hear it. So Dave, can I just get a note or thumbs up from you that we look good here? Okay, so today, myself, as well as Nick Guild and Keith Hurley, are going to be doing just a little presentation about building and maintaining databases for managing fisheries data. And so I'm going to kind of start things off with just a kind of broad overview of some of the important considerations of this kind of effort. So the portion I'm going to talk about is kind of these basic data management considerations, and I'm going to talk a little bit about planning database architecture, and then as well as just some kind of data management stuff like quality or completeness and accuracy, metadata, storage, and access. And this is all related, or a lot of the portion I'm going to be speaking about is related to a book chapter we have coming out here that covers this. So that's going to be hopefully released here this summer. So if folks have more questions about that too, I'd be happy to share that with them. So the first thing that we kind of encourage or are thinking about encouraging people to think about when they're undertaking a project is the kind of planning phase of data management. And one of the first things we want to talk about a little bit is before you get started on any kind of planning of your project, it's really important to review related projects. These could be kind of projects that were similar that took place before. So if you're doing, conducting angler surveys, a great idea is to look at has the organization you're a part of done angler surveys in the past? And what can you do to make your data collection, either your methodologies or your survey methodology, but also the actual like how you're managing the data, consistent with those past efforts. If there's ways you can kind of standardize things, you're obviously going to gain a lot more insight if you can combine those data sets. So we really recommend reviewing related projects and seeing what you can do to potentially make it so the data you're collecting can be integrated with those other projects. It's also important, I say related projects, it doesn't just need to be the same type of project like a previous angler survey. It's also kind of other information that might be able to be used in conjunction with it. So thinking about things like, are you using water body information? If so, like how can you connect the data you're collecting to that source information for the water bodies? Or maybe being able to compare your angler survey data with biological survey data is going to be important. And thinking about how you can structure and arrange your data and collect it so it best matches up with some of that related information is really critical. As part of the planning process, you obviously want to think about the information needs. What questions do you want to answer? And that's going to obviously inform your study design, but it's also going to inform how you go about collecting your data and then structuring it when you're compiling it. So thinking about what questions you actually have to answer and then how best to store your data and collect your data so that you can use it to answer those questions. And then finally, I was just going to mention really useful to consider potential future uses of the data. So maybe you're trying to answer a specific question by conducting an angler survey. Maybe you're looking at like setting some new length limits for a taxa. You know, if you're out there collecting data, there might be other pieces of information you can collect that are going to be important, you know, a couple years down the road, and it'd be easy to collect at the same time. So maybe it's easy to throw in some information about like where anglers are coming from and collect zip code data, or get some information about economics and how much they're spending, even if that's not directly influencing your question right now. If you can easily collect that data, you know, at the same time, and it's not adding a lot of survey burden to it, it might be worth considering what else you might want to collect now to help kind of facilitate future use of that data set. So a little just kind of brief thing about data architecture. So 3 of the ways that data is often stored from these projects or after an angler survey project, kind of the simplest is just recording information in documents and reports, right? You got a Word document where you wrote up your report about your survey, and you have the information of like, these are the harvest rates, or this was total estimated catch, or so on and so forth. While that's kind of okay, it presents a lot of limitations as far as being able to use that data in the future. And so I would recommend that folks, when they're doing this, they really steer clear of just having those final reports be the end all of their data. Try to put it in some format that can be accessible and used at a later date. For really simplistic simple data sets, you can use tabular data or flat files. That's something like an Excel spreadsheet. And that can work okay, but we'll go into here. We really want to focus on the use of relational databases and why that's kind of incredibly valuable, and it will help your data be used for a lot more purposes, be a lot easier to access, and there's a bunch of other benefits that we're going to kind of get into as we go. So the real simple picture of a relational database, and Nick, who's presenting after me, is going to get into kind of how this actually looks and give some more information, but they're typically tables that have some hierarchical structure. So you're going to have information, maybe some of the information you're collecting in the survey is at the level of individual species. Some of it might be individual interviews, but then you're also going to have higher levels, information about the water body or the survey methodology and effort. And all these different tables are going to be linked together using primary keys. So you can have information in different tables that can be joined together, and you can pull stuff out of based on what you need. And the benefits of this, one of the primary benefit, or one of the primary benefits of this, is a relational database that can be accessed by a variety of people who want to work with the data, presents this single version of the truth. So you're not going to have separate files on different people's computers, and someone's using the version that's labeled like survey data 11_23, and someone else is using the 2022 version, and so on and so forth. Everyone goes in and they use the same database, and they pull their data out of it to use for their analyses, and then everyone is working from that kind of single version of the truth. Relational databases are great. They minimize redundancy. So we're talking about the hierarchical nature of these data sets. Instead of having a field in your data set that's lake name, and you have an observation for every single species, you don't have that lake name listed over and over and over. You just have a single column with that unique identifier, and then you don't have to duplicate all that information. You just link to it and it all kind of comes together. So it helps make a much more efficient data structure. It uses a lot less memory, and you have a lot less kind of stuff you have to try to sift through. Queries are really nice. So when you're working with a relational database, you can run queries, and that's going to provide targeted access to the data. So if you have a big data set, you might not want to filter through 20,000, 100,000, a million records, or you might have hundreds and hundreds of fields, and you're only interested in a subset of that information instead of having to manually go in a spreadsheet or something like that and pull out just those records you're interested in. You can write a really quick, easy query, and boom, you have the data you need. And so you get that targeted access. And then finally, you can protect data integrity with it. So typically, you can have one of these databases developed, and you're backing it up, and you can limit write access and things like that. So you don't have to worry about, either intentional changes or accidental changes being made to the data set. Intentional changes, you can obviously kind of record what's going on there. You can have versioning and a lot of stuff to kind of protect that integrity. So that's the big reason. Those are some of the kind of real benefits of this kind of approach, and it's going to kind of really help protect the integrity of the data. So I also just wanted to go over some other basics about the data. So when you're setting it up, you're obviously going to want your columns or your fields, you're going to have information about them, the type of information. So that's going to be, is it a number? Is it a factor? Is it a character string? And then attributes of them. So definitions of what that field actually means. And then also the use of fields in these databases allows you to kind of constrain and validate. So something that's a factor, you have a list of species. You're not going to have people writing largemouth bass and LMB and whatever other names for the same taxa. You can constrain it to a specified taxa name or code or range of dates or range of times to prevent kind of entries that are either an error or just inconsistent, and so it makes it hard to use the data. Completeness is another important factor. So you want to make sure you're retaining all relevant data. And definitely, I recommend prioritizing keeping that kind of fine scale data over summarizations. So if you keep information on catch, like total catch estimate and total effort, that's going to be a lot more valuable than just retaining like catch per hour. Because if you have that catch per hour and you don't have either catch or effort, you can't back calculate to those other metrics. And so if you want to be able to use this data later on for things, even if you're only interested in catch per unit effort, keeping those kind of source data sets or source fields that were used to calculate that information is important, because you can't always back calculate things if you don't have all of the kind of fine scale information you need. And I'm going through kind of this pretty quickly because I want to obviously leave time for everybody else. But we talked about this a little bit earlier as far as accuracy goes. You want to make sure the data in your database is accurate. And there's a lot of tools for doing that. So bounding your data entry, you can have discrete sets of classes. So it could be only these lakes or these counties or these taxa. And so you limit it. You can also have minimum and maximum values in place, so you don't have information that's like way out of range. Or if someone tries to put something in that's kind of an error or out of range, it'll flag it so you can kind of figure out what's going on and deal with it. You can have obviously different standards you set in place, and it's also important to confirm that any of these ID fields, key fields, whatever you want to call them, are unique, because having those unique identifiers, if they're not unique, they cause a lot of problems. So that's some of the things we'd recommend checking for accuracy. And then finally, metadata is often overlooked, but it's incredibly important. It's just basically documenting the data set. So you're going to want to include information about the scope of the study, the methodology that was used. For any of the information in the actual tables, you're going to want to have information about the name of the field, the format of it. So if you have a date, you want to make sure to say whether it's month, day, year, month, year, month, day, etc. And just the units of these variables. You always want to make sure to use unambiguous formats. You don't want anything to have someone access the data and be like, unsure of how to interpret it. So the example of this again is going to be dates. And if you don't know what if it's day or month first, that's obviously can be ambiguous. So selecting things that make it either clear or defining it is really important, and having that documented. And then obviously if any of your fields are based on calculations or summarization. So for example, if you're calculating like percentage of or you're calculating like angler preference in your you're calculating angler preference and you have a column that's like percentage of preference or something like that. What percent of anglers are targeting X species? Documenting how you're actually calculating that is really important. Is that based on a percentage of angler hours? Is that based on a percentage of interviews? Are anglers only allowed to select one taxa? Can they select multiple? There's a lot of different ways you could calculate something. And so documenting how those calculations are actually done is really important for interpreting it and using it. And finally, you want to definitely store that metadata in an open, non-proprietary format, so something like an XML file. And metadata has a lot of great standards that you can kind of make sure your metadata conform to. So I'd recommend investigating a set of standards and trying to use those. There's a lot of great resources for doing that. Obviously, we want to encourage people to avoid local storage. You don't want your information being lost or forgotten. There's a lot of great options for network and cloud-based storage. So the benefits of those are they can have permission-based access. They're a lot easier to find. They're not going to get lost, hopefully, much less likely that they're going to be lost. And they can be accessible to a number of people simultaneously. You don't have having to go to one person to get a copy of the file or whatever. So I am going to hand it off to Nick, and I'm going to stop sharing, and he'll take over.
Thank you, Nick. All right. So yeah, Nick just gave you a great introduction to some database terminology and talk about how these different aspects work together. And I want to talk about how me and others at TBWD use our database demonstrated through a case study. Before doing that, I want to share with y'all some highbrow database themed memes I made that kind of drive home some of these points we're making here. Right. Oops, there we go. All right. I often hear people talk about Excel as a database. Excel is not a database. It will never be a database. It is a spreadsheet program that has more mission creep than any piece of software I've ever seen, but it is very much not a database. Look at this dog. This dog is trying to use Excel as a database. Look at all these problems this dog is having. He's shoebox data. He has biologists that have spreadsheets that they keep locally that other people don't have access to. There's duplicate work being done because no one else knows what people are working on. You have data loss like Nick talked about. You also have security concerns, and you have pain and frustration. This dog may say he's fine, but this dog is not fine. This dog is having a very bad time. Look at this man. This man represents an agency who is having to do the Sisyphean task of writing 0 every day for every day that they're at work because they have data loss all the time. A database allows you to eliminate a lot of the issues that go into causing data loss and make sure that your workflow and yourself and everyone else in your agency is much smoother. There's no hiccups. Everything is right where it should be. Look at these two dogs. The dog on the left is a relational database. The dog on the right is an Excel spreadsheet. The dog on the left, scalable, secure access. There's one version of the truth, and there's a live connection. The poor dog on the right thinks 100,000 records is a lot. It's unreliable. There's plenty of insecurities, and it doesn't believe in anything but its truth. Someone can have one version of a document, like Nick was saying, and then someone else can have a different version, and they compute values differently. And so everyone is working with different numbers. And when you try to collaborate, it makes it very difficult. So we want to be like the dog on the left. You. This is you having a nice breakfast, very successful, looking very cute. And you realize that my agency should build a database. Right. Now, before talking about that case study, I do want to give some background information about the database system we use here at Texas Parks and Wildlife. We use a program called SAS to house and communicate with our database. Our SAS system was built in-house by some brilliant and forward-thinking men and women whose shoulders I am very lucky to be standing on here. SAS contains all of our data, whether that's creel reports, customer license data, everything is in there. Every night, we conduct an ETL, which is an extract, transform, load process, which takes all the data from all these different sources. It puts it in a format that is universal so that there's no mismatches, there's no errors, everything is of the same type. And then it takes it from a staging table into the database itself. This process is how we update our data and be easily implemented using a tool like Microsoft Scheduler. It allows for that single version of the truth Nick was talking about, and it's automatically updated. And kind of going further into it, this single version or one version of the truth means that if I have a question about a table, I can hop on a call with Keith and he can pull up the same information and work through it with me. And so we can work collaboratively. It helps facilitate communication in a sense as a second order effect. Because everyone has access to the same information, collaborative work isn't cumbersome. There's not 5 versions of the same Excel file being passed around over email or OneDrive. It's a uniform environment that allows for a more agile workflow for everyone involved. Here, we've got a screen grab of SAS. This is the graphical user interface or GUI. That's called the SAS Enterprise Guide. I kind of think of it similar to R Studio and R and how R Studio kind of lets you work with R data. Look here. All right. Whoops, that's a terrible mistake. Sorry. Here we have our process flow. This is our visual representation of what you're doing. So right here we have our pause rep. Oh, I'm sorry, you can't see my mouse. Yeah, switch that. We have our source tables here. These are pulled from our SAS file directory. So this is our database directory. I can just drag and drop these, and that's a no-code deal. A lot of happens under the hood, and we can look at how that's done. But this is really easy to work with. It's just drag and drop here. So we have our source tables, then we have our operations that we're performing. And here we have our project panel, which is basically just a top-down representation of the work that you've done. From here, I can go in, I can schedule tasks, I can write projects in SQL to do certain operations. I can schedule things, like I said, I can do tasks, perform a wide variety of analytics. It's just a very easy way to navigate working with databases. All right, so that case study. I think it's something y'all might appreciate. It's kind of a use case I'm proud of. I do work a lot with our human dimensions work. I don't know if Zach Taylor's on this call, but he's our in-house human dimensions expert at TBWD, and this is something I thought he would be proud of. I'm in charge of running our biannual customer satisfaction survey. And in the past, before I was given this project, the survey was run using convenience sample. Users who visited the website during a 2-week period in February would be served a pop-up prompting them to take part in the survey. This worked, but obviously this is not a representative or randomized sample of our customer base, which of course limits its validity. And when it comes to understanding how we're doing with our customers, you want to have external validity. And so for me, when I'm given a task, it's going to take up a significant portion of my time. I want to be proud of the work I'm doing, and I'm sure everyone here feels the same way. It's not going to be a good product. Why put it on the shelves, right? So what I needed was a low-cost, efficient method for gathering a representative sample of our customer population, not just consumptive users, but non-consumptive as well. That's a tall order on a tight time frame, but thankfully, because of our SAS data warehouse, specifically a database known internally as LURES, which stands for License Utilization and Revenue Enhancement System, which functions as our CRM, our customer research, or customer relationship management, excuse me. It's a database that collects and appends all of our customers, whether state park pass holders, saltwater anglers, and assigns them that global unique identifier that Nick talked about, which I like to think of as like your driver's license or driver's license number or social security number. It's a number that follows you everywhere you go. So every interaction that you have with your agency or this customer has with your agency, it's the same. So there's no confusion. There's no data corruption or just misalignment, you can be sure that because you have this global unique identifier, that every interaction where this customer returns is them. And it makes everything so much easier to work with. So let's look at, okay. Can I just click on this? Mess this up. Sorry, I did not. I'm trying to click here. There we go. Okay, so let's look at the source table for licensed customers. This is a little bit of a you could stretch it and say this is a data dictionary, but this is what Nick was showing earlier. We have the name of the table, the data type. You see, we've got numeric, we've got character or string, we've got date time objects. If I was to scroll farther down here, you would see financial data, things like that. We have the length of the data field, we have the format of it, we have a label that you can use as a descriptor if you did want to use this as a data dictionary. And let's look at what it looks like to manipulate this data. Here we have a neat little interface. Again, no code here, right? This is just drag and drop. I can take all these fields that I want that are on the source table, and I can plug them in here for the output. So if I want the transaction posting timestamp, I just click this and drop it. So you've got options here for filtering, for sorting. We can create new computed columns that will then be accessible by other people that are using the same project. So again, like you don't have duplicate work and you have a single version of what you're trying to do. And again, like this is no code, but sometimes you either want to look at the code or you want to write your own code because you want more control. And this is what this is doing under the hood. All this SQL code here is being done by this drag and drop system that we have here. I could write this manually, and again, sometimes I do, but it's not necessary. A database, I think sometimes can sound intimidating to work with, but oftentimes it's really not. For your users, your end users, you don't have to be some wizard with SQL or C# or something like that. You can be as programmatically oriented as you want, but you can do a lot of this stuff without having that sort of background, which I think is great and is something that maybe isn't talked about enough. So zooming back out to the case study, I was able to create a process that pulled all of our customer tables from, which is right, tens of millions of people. It's a lot. We live in Texas. I selected the columns I need. I was able to filter for the time frame, and then I wrote a program using SQL that created a randomized sample of 52,000 customers, and did all this about an hour. I mean, that's an incredible level of efficiency that we're talking about. You can do so many things that you work on now that if you don't have a database for, that you're using so much more time than you could be with a more efficient system like SAS or whatever sort of database solution that you're looking for. And it just really is this great force multiplier. And I'm going to turn it over to Keith, who's going to talk about the considerations for the development of a database like that.
Nick, can I get a thumbs if you hear me?
Yes.
Fantastic. All right. For the next little session here, everything is going to be in this little box. So you can just blow my webcam up big, and that's where you're going to be able to see everything we're going to be talking about. So let me set up here, and here we go. Ladies and gentlemen, my name is Keith Hurley. Excuse me just a second. I'll get this out of the way. Technical difficulties as always. All right. My name is Keith Hurley. I come to you from the Nebraska Game and Parks Fisheries Research Section. I've been working with creel studies and data and human dimension studies and data for 2 decades now, and a lot longer than that in the database world. And as you can tell, Nick and I were pretty passionate about this stuff. So as we talked about putting this together, we wanted to make sure we were providing information that would help you moving forward, because it is kind of big and it's kind of a scary world, and it gets very technical and very complex in a hurry. I mean, there used to be a day where you could grab maybe a technician that had some computer chops, or an old grizzled fish squeezer that been working with the old computers from the early days, lock them in a conference room, feed them pizza and Jolt and Mountain Dew, and a week later they'd come out with some form of a database that would function and work well for you. But things are getting complex. I think Nick did a great job of showing some of that. Some of those days are over. If your database is served more than one person or more than one location, it's really hard to get by with that kind of an approach. And so this day and age, typically, if you're going to want to create a new, I call them data system, something beyond just a single study database, and that's what we do, right? If I'm going to make a Creel database, I'm going to make it work for everybody in my state. When we do that now, we actually have to bring in some kind of an external group. We might bid and contract out with a computer development group, company or corporation. It may be internal groups from your agencies or your government's CIO or IT resources. But at the end of the day, now we're working with a very different group of people. These people know a whole lot about technology and very little about the job that we do. And yet we're still trying to serve the same end users, and so they speak different languages. It gets even more complicated than that right now, because when you start bringing in contracts and external groups, we also got to talk funding, which means now we have to talk with administration and the people that control the purse strings and allocate resources in our agencies. So at the center of this little bit of turmoil here is somebody that we call a project manager. In order to get database projects done, especially moderate to large scale projects these days, somebody sits in the middle of all these groups and is responsible for getting the job done. Ladies and gentlemen, there's people on this call that have done this many times over. And if you're on this call, congratulations, this is you, and you have my condolences. This is the role that largely we play today when we say it's time to develop a database. And so what we wanted to do as we wrap up today is maybe give you some advice from the three of us as to how to approach these different groups, things to keep in mind when working in this kind of environment. If you're going to be the person that's at the head of the food chain, so to speak, to get a project done, here are some things we think you might like to know, things we wish we were told when we got started. So moving forward, obviously starting a project, you got to get some funding, you got to get some resources, you got to get some interactions with your administration. And so here's the secret about administrators. Making your job easier is not a priority for them. Period. Now, that's harsh, and that's not true. They want our lives to not only be easy, but efficient. But when we take developing a computer software application and stack it up against things like putting boots in the field, tractors in the dirt, fish on the hauling tank, it's hard to be prioritized in that environment, right? And we all have limited resources. So how do you approach administration to try to raise the level at which this type of work can be prioritized? First thing I'm going to tell you is to make sure that you go out there and you find yourself a champion, someone to carry the banner for you. This is not you. It cannot be you. Anyone that brings their own project forward, of course, is supportive of it. What you need to do is find someone that can benefit from the project, from whatever database you want to design, create, and use, in addition to the work that you want to get done. Think laterally. Think other sections, divisions, agencies that if you modernize your data, they may be able to get more done. Because now you start talking about breaking down silos. You start talking about interagency collaboration and cooperation, all that good language that administrators like to speak. Find someone in one of those areas that can help carry the banner for you, and talk to your administrators as well to try to raise your visibility. And then start working on putting things into the proper context. And this is a mistake I've made and I've seen a lot of people make, but if you're going to get funding and you need to talk to the policymakers and the decision makers, put things in their context, which is different than what we want to see out of a project. So keep that difference in mind. Administrators work with the 3 M's. Do you know the 3 M's? Money, manpower, and mission. And so anything you bring up and talk about, try to put into that context. I can save every one of our field staff 5 hours a month if we get this put into production and into play for our staff, and then you can start putting pen and paper to pencil and figure out, hey, we now have 2, 3, 4 additional man weeks of effort that are putting boots on the ground, that are putting fish on the hauling truck. So put things into money, dollars and cents, and manpower, and you're a lot more likely to get support along the way. The other way context comes into play is sometimes you have to do a little bit of a show and tell. We have an open fields and waters program here in Nebraska where we lease out private land for fishing and hunting purposes. When that program started, they had 2 employees, and one employee's job was to handle the contracts, 3 big file cabinets of contracts. She spent 30 to 35 hours a week going through that file cabinet, tallying up totals, creating reports for data requests. That was most of her job and was all done manually. They asked if they could get a database put together. No, the resources don't exist. So we actually sat down, made a little access database that had a lot of the work that she had to do, and we dropped that down to about 5 hours a week for her. Suddenly, she had a lot of time to do other things. Fast forward 2 or 3 years, suddenly, hey, we need to make this database bigger, broader, statewide, online. Resources were suddenly available because we did a show and tell and put things into a context that people could understand. Very important aspect, trying to find that funding. But the third piece we like to tell you here is avoid any kind of a kitchen sink database project. And this is for your sanity as much as trying to get funding for a project. Kitchen sink approaches. I've seen places that start off trying to create a data entry program for fish sampling, netting and electrofishing, and suddenly, oh, we need habitat in there, and we need AIS reporting in there, and now we need to do fish kill investigations, and we're going to put all this into the same project because you hear these phrases like, if we're going to do this, we're going to do it all at once, or we're going to do this right the first time we do this. And it leads to these gigantic kitchen sink projects, which first off, they get very complex. Anytime you bring disparate data together, somebody has to compromise to make things work. And so nobody actually gets everything that they want. And along the way, prices rise, resources rise, and things tend to implode just under the size of the projects. It's much better off, if you're a project manager trying to drive forward with a project, to keep a narrow, defined focus. What problem you're trying to solve, how are you trying to bring this data forward, and what's it going to do, and resist all urges to just keep throwing additional components into the project. At the end of the day, you're going to be successful, you're going to create a reputation for doing good things, and that funding will be easier to get every time you go back after that. So 3 pieces of advice from us to you when you have to go out and try and seek some resources. But when you are successful, and you will be, it's time to get the project done, right? And that means you need to start working with the users, your biologists, your technicians, your researchers, your office staff, whoever it might be that's going to use this data system you want to put into play. And here's the secret about database projects when it comes to users. Even if a project is totally successful from the standpoint of it does every function it was asked to do, meets every requirement that was ever written, it can still be loathed and hated by employees. Perception will play as much of a role in the success of a project as the actual functionality that you put into place. It's just the way the world works. So our advice to you here is to make sure from the very beginning that you involve these end users. The people that use the software in the end need to be at the table immediately when you start your project. Obviously, there's a period of time where you're going to sit down, kind of put together your list of requirements, what the database needs to do, what functions, what reports, what data, all that stuff that needs to be accumulated and documented. Involve as many end users in that as you can. And I advise people, reach farther down the hierarchy. If someone tells you, yeah, the regional supervisors can tell you what we need for a Creel database, say, hey, how about we bring in the biologists that are supervising the field staff too? Maybe we can bring in the Creel clerks that are taking the data, and they might have a little bit different perspective. All this work does a couple of things. One, it makes sure as a project manager, we get the biggest picture that we can get as to what this database needs to do. More importantly, in my mind, it starts to create what is called the empowerment effect, right? We are listening to people, and people want to be heard. And if they're heard, even if you don't take all their advice, they feel like they're part of the process. Then the empowerment effect kicks into play. Now they're looking for reasons for this project to succeed rather than trying to find reasons to criticize it and for it to fail. And so we want to involve everybody as much as we can early on. As you go through development, as you build out your database, give them updates. Don't let them sit in the dark and wait for 3 years before they know something's going on. Update them, share some of the good stuff that's happening, share some teaser screenshots so they feel like they're part of the process. That way, when you come to rollout, they are looking for the good stuff that you're going to provide. I am, by definition, I believe in benevolent dictators when it comes to being efficient and getting work done. However, in software design and database design and creating these types of systems, it doesn't work well. I have become a big believer in using advisory committees, work committees, you might call it a lot of different things, but what I tend to try to do now is to go out to those end users that you talked to when you were gathering your requirements. I'm going to find 2 or 3 people that are a little bit tech savvy, people that can break out of that box of what history was and see what technology can add to what they're already doing, people that will be using the software in the end, and most importantly, people that have the respect of the peers and the other end users they work with. That group of people is going to make the decisions for pretty much everything we do moving forward. As a project manager, it's really hard to cede that control, even in those situations where I really know a lot about the business and the technical matter we're working with. However, it will make a better product in the end. So I view my job a lot more as to working with the developers, translating what they say, and passing that decision to this committee and saying, we can do A or B, here's the implications, what works better for you? Using those people to make decisions will create a better product. And then when it comes time to roll out, you can have them introduce a product. You put them up there, they can train the people that are going to be using the product. And by virtue of them being one of the crowd, you're going to see a lot better acceptance of the project at the end. And this is a tough one to really understand, but focus on process when you're talking to your users, not on the implementation. For whatever reason, when you set somebody down and talk about creating a database, creating a system of some sort, it's immediately, I want a button here that makes a report. I want a text field here that does this. That's the how. Our developers can do the how. They might come up with a lot more creative way to make the how a lot easier for the users. When you're talking to the end users, talk about the why, how things fit together. Okay, I hear you want a report. What data is in that report? Do you need that? Is that something you're going to open this application up and get once a week? Pay periods? Is it something you need in the middle of data collection, at the end of data collection? Look to the process of how that data is going to get used, and then start to fit the how the developers come up with into the why from the end user. Which brings us to this group. This is the scary group. If you've never worked with a group of programmers and nerds before, sorry, Nick, I'm not talking about you. They don't speak the same language as the rest of us. They may as well be speaking Klingon, right? And it's the project manager's role to take what they say and make it understandable for those end users to make decisions with. And so it's really hard to sit here and give you advice on how to do that, but what we can sit here and give you some advice on is how to pick the right development team to work with. Because here's the secret about programmers. They don't have the same goal that the rest of us do. We have the goal of creating an efficient, effective program that's going to make our lives easier and do good things. Development groups, their objective is to make money. They make money by getting the project done as efficiently and quickly as possible, meeting all the requirements in their contract, and getting that done and moving to the next contract. So there are shops out there that will largely focus on completing projects as quickly as possible, and maybe not giving all the onus to making sure that product is exactly what will serve us the best. Here's some canaries in the coal mine I'm going to tell you to look for when you're starting to try to find groups to work with. First off, try to find a development group that wants to include some sort of a visioning process. When you start making a database, obviously at this point you've talked to your end users, you've made kind of a list of what you want the database to do, you've went out, you've bid a contract, you get it back. Look for those groups that still want to sit down with your end users and say, how does this work? It might be things like use cases, user stories, wireframing, a lot of different methodologies that may be used, but any developer group that wants to do that means they want to understand your processes. They want to make sure what they create fits into your workflow and your data flow. So groups that want to do that are a very good sign. Avoid those groups that just want you to pass along that contract and they're going to go get to work and they'll come back and give you a good product, which leads us to the two different ways software that can be written. Software these days is written either in a waterfall method. That means basically you make a huge binder of every possible thing you want included. You hand that out to the developer. They come back 3 years later and give you a product. These are not your friends. Look for the groups that work in an agile methodology. This is an iterative methodology. What they do is get just a general idea of what you're after. They're going to work for 2 weeks on a part of that. Bring it back, bring in the project manager, and I bring in that advisory committee I put together, and we sit down and they show us what they've got, and we can offer advice on that. They're going to ask for any decisions that need to get made, and then they're going to do the next little chunk and the next little chunk, but it keeps us involved throughout the entire process. That will lead to a lot better product in the end, but it also means you are now working with a development group that cares that the product meets what you want to see. And the final thing is, and this one sounds a little weird coming from a government agency, right? But insist that your developers work on aesthetics as well. It's easy to say we don't need to spend money on aesthetics. We have a captive audience. They will use whatever we give them. However, remember, acceptance of a new database program is going to be largely based on perception. So you don't have to go overboard here, but developers that are going to spend a little bit of time on branding the program, creating decent color schemes, using graphics that look nice, rather than turning out something that's a battleship gray with small buttons that looks like it was made for Windows 3.1, it's going to make a big difference to your users in the end. The functionality is the same, but they will feel better about the program. They will feel better about the product that you give them. So look for those developers that are willing to do that type of activity. And I've kind of burned through stuff there pretty quick, but I know we're at the end of our time. So I just want to give a few more pieces of advice to those lucky souls among us that are going to have to fill the role of a project manager. For your own safety and your own sanity, understand that if you take on this role, that you're going to have to do some education. We don't know the tech world like we should or like we need to do these projects. We don't have to become high-level coders to make it happen and work as a program manager, but we're going to have to start to figure out the alternatives, the pluses and the minuses. So as we translate this information to our users and our advisory committees and our work groups, we can give them good information, right? So understand that you're going to have to educate yourself and spend some time on that. Understand that the best way to approach this is to make sure that you facilitate more than dictate. And this is just lessons I've learned through life as a project manager. My job is to make sure that the end users are driving this boat. They're making the decisions. I want to facilitate them creating great things more than telling people what to do. It's a hugely different way to work, but it works so much better for the purposes of creating the product that you want in the end. And the last thing is something that never ceases to amaze me is that spend some time managing expectations. For whatever reason, when we're talking about technology, and those people, all of you on this call, you have experience with technology, you know how to work with it, but when you go to someone that doesn't know a database from an Excel spreadsheet, it becomes magic. And suddenly, well, it's not that hard to write a report. It's not that hard to make a button that does this for me. They don't know what's in the background. It's magic. It's easy to do. And so spend some time to manage expectations. This is what this project will accomplish. This is what it won't do. This is how long it might take. This is how long it probably will take. Manage your expectations so when you get to your launch, when you get to your rollout of that database, people feel like they've succeeded rather than wondering why you haven't given them what they wanted, not realizing it wasn't possible in the first place. And so I kind of burned through that fast, but that's some advice from Nick and myself to you, because largely if you're going to start creating databases, largely this is the environment you're going to be in. You're going to be hiring people and working with people, and it's a lot more about keeping the process running, the training running to get a good result. And so we are going to be here throughout the call today. Dave, I'll leave that up to you if there's any time for some comments, questions, and discussion now. But if not, we're going to be in the chat. We're going to be around and happy to talk. And we'd love for you to reach out to us individually. Obviously, we're passionate. We love to talk about data. And we'd be more than happy to spend time talking databases with anyone that wants to. So ladies and gentlemen, thank you for your time today. Thank you for the opportunity.
Thanks, y'all. That was really great. Sorry, I'm getting an echo here. Josh, actually we have time for just one quick question, and if not, maybe you can throw your questions in the chat. But we are running a little over time here. But does anybody have a quick question for Keith or either of the Nicks? All right. Well, yeah, with that, really appreciate the work y'all did. Oh, it looks like we got a question from Mark. Go ahead, Mark.
I was just curious, how long do you guys think of retaining your actual hard data, your handwritten data for retention?
I'm an old biologist by heart. I hate throwing out hard data, but I think one of the things in Nebraska we do a lot now, especially with a lot of our research projects, is we tend to scan things, so we keep it indefinitely. We'll digitize it, scan data sheets into PDFs, and store them in a server file alongside the databases, and that way we have them in the future. But that's probably one of the approaches we've been taking.
All right.
Yeah, I would agree with that. I mean, sometimes there's statutory concerns that we have to worry about with data management, but as long as you're meeting those requirements, I think that digitizing is the best way to do that for historic data.
Awesome, y'all. Thanks for sharing us. Great presentation, and as y'all said, feel free to throw things in the chat if you have any questions for those. Yeah, thanks a lot. And with that, let's move on to Josh. You can go ahead and share your screen. Josh is with Idaho Department of Fish and Game, and he's going to talk about some state-based models for creel estimation today.
All right, thanks, Dave. Can you see my screen all right?
Yep, looks good.
Okay. Yeah, so today I'm going to talk about state-based models for creel surveys, and this talk is based on a paper that's published in Transactions, so you can go look for that. If you can't find it, send me an email and I can send it to you. So just to start off, I'm sorry, it was taking a second for my slide to advance. I'm just going to talk about kind of the way that I think about population dynamics just in general, and how we estimate things about populations. And so, so there's things that happen to populations, and a lot of times with populations, the state of the population at a given time depends on what happened to the population previously. And rarely do we ever actually observe the population as a whole at any given time. We observe something about the population, and hopefully the thing that we observe about the population depends on what's happening in the population. And I'm just going to walk through a little example of these two things. And with both of them, there's certain parameters that govern both what happens to the population and things that we observe about the population. And so things that happen to a population, this figure on the right shows a hypothetical population. On the x-axis is time t, and on the y-axis is abundance. And so there's some equation that we can use to model that population. And this is a pretty simple one. This is just an exponential growth model where the abundance of the population at time t is equal to the abundance at the previous time step times some change in the population, which I'm going to call lambda. So in this case, lambda is the parameter that governs the population. And in this example, if we set that to 1.01, we get the figure on the right. So at any given time, the population increases by 1%. But the reality of populations is they look like this. You don't actually have the population increase by 1%. Sometimes it can increase by more, sometimes it can increase by less, or it can decrease. So we have to add another parameter to our model, which is just the error term. And so this is going to be known as process error in a state-based model. And now this model fully describes what happens to this population in this case. Now, when it comes to observing the population, if we were interested in estimating abundance at any given time period, we're not actually going to be able to estimate abundance exactly. Sometimes we're going to overestimate abundance, and sometimes we're going to underestimate abundance. So the mathematical equation that describes this is this equation that I just put on the screen. So the data that we collect for the population is equal to the abundance of the population plus some level of error. Sometimes we may overestimate abundance, sometimes we might underestimate abundance. And this is the general theory that underlies state-based models. So maybe in a more traditional kind of exponential population growth model, all you have is the data that you collect and you treat that as what's happened to the population and the data that you observe. But a state-based model models these two processes separately. And the first part of that is known as the process model, and the second part is known as the observation model. And to get back to my first slide, the abundance at a given time is conditional on the abundance at the previous time step, and the data that we observed is conditional on the actual abundance of the population that we don't actually observe. And these two things are kind of what makes state-based models state-based models. There's lots of variability kind of available for any way you want to model the process model, the observation model, but these two kind of critical properties make them state-based models. And a majority of the state-based models in ecology are applied to either fish populations or wildlife populations, but they potentially can also be applied to populations of anglers. And kind of traditionally, we estimate things about populations of anglers using creel surveys. And one of the things that we want to estimate oftentimes in creel surveys is angling effort. And so this can be in the form of the number of angler hours or the number of angler trips or anything like that. And traditionally, the way that we estimate this is by conducting angler counts. So this is our sample. And this can be used very broadly. This can be instantaneous counts or progressive counts or counts of the hours of time that anglers spent fishing as they're leaving the fishery. This is really just a general statement about observing things about the angling population. And traditionally, these are design-based, meaning that the estimates of angling effort are asymptotically unbiased because of the design that we used. So we use a probabilistic survey in many cases, so we know what the probability of observing the data are that we collected, and that's how our estimates are unbiased. And a lot of times in creel surveys, there is day type stratification. So generally fishing effort is higher in recreational fisheries on weekends than weekdays. And so we might implement some type of stratification in an effort to reduce our variance of our effort estimates. However, within those strata, generally the observations are considered to be independent. So there's no information used about one day where we sample to provide information about the following day that we sample. But if you look at fishing effort data, so this is a figure from a fishing access point on Cascade Reservoir, just north here of Boise. On the x-axis is the day of the survey, and on the y-axis is the number of anglers. And this is about as close to a census as you can get as the number of anglers fishing someplace. We measured this using a remote traffic counter. And you can see that generally when the number of anglers is high, the following day or the previous day, it's also high. And then when it's low, it's also low. So there is some level of temporal autocorrelation that generally happens with populations of anglers, but many times that's ignored. Which brings us to the objectives of this analysis, which was to develop state space models for creel surveys. And the main purpose was to account for this temporal autocorrelation that often exists with angling populations. And so to do this, when we want to use a state space model, we first need to define the process model and the observation model. And in this case, I'm just going to use this exponential population growth model that I described earlier. However, when it comes to the observation model, we need to do some tweaks here. So in this case, Y sub T is the data that we collected, so the counts of anglers. And at any given time, when you do a survey, you don't ever count the entire angling population as a whole. So if we're saying that this is equal to the actual number of anglers plus some error, our estimates are going to be systematically biased because we don't ever count the entire population at once. And so in that case, we would underestimate it. So we're going to modify this equation and we're going to add this other parameter here, pi. And this is just the design-based estimator parameter that you would get if you're doing a normal design-based creel survey. So we're going to leave the process model the same and we're going to change the observation model slightly. We're also interested in estimating day type effects. So as I mentioned, we know that angling effort is likely higher on weekends than weekdays. So we're going to take this lambda parameter here, which describes the change in the population through time, and we're going to embed a regression model to estimate how that parameter changes on average as we change among day types. And we just embed this in the same model that we previously did. So we did these surveys at 3 places in Idaho, in Southeast Idaho. These are all catch and release trout fisheries. The first place is the Big Lost River. This is a catch and release, mostly a catch and release rainbow trout fishery. A majority of the angling that takes place there is by bank anglers. And there's one section within the Big Lost River where we're interested for this study. We also did the surveys on the Henry's Fork of the Snake River. This is a very popular catch and release, mostly trout fishery. There is a mix of bank anglers and boat anglers that takes place there. And we also did the survey on the South Fork of the Snake River. And I should mention that we divided the Henry's Fork of the Snake River into 7 sections, 7 different sections based on kind of like the geography of the area and how that breaks up. The South Fork of the Snake River, also a catch and release trout fishery. A majority of the effort takes place by boat, but also some bank anglers. We broke this down into 3 sections. And so for all these creel surveys, we sampled 4 days a week, and we did multiple instantaneous counts, kind of as you would in a traditional creel survey to estimate angling effort. So this figure shows the uppermost section of the South Fork of the Snake River. And so on the x-axis is the day of the survey, and on the y-axis is the effort estimate. And so this is what we would get if we just did it, if we treated these days as independently using kind of traditional design-based estimators. This is what we would get. And so we fit our state space model to these data, and you can see that our estimates line up pretty well with our design-based estimators. So this gives us some indication that the model is working. And you can also see those kind of peaks and valleys, and that's when we switch from weekends to weekdays and vice versa. And so this looks pretty similar to our census effort that we had at Cascade Reservoir. So I mentioned that we embed a regression model to estimate the day type effects. And in this case, this is the slope parameter that tells us how the effort changes as we switch from one day type to the next. And it's multiplicative in this case. So any estimate of a coefficient that's less than 1 suggests the effort is decreasing. If it's equal to 1, it suggests there's no change. And if it's greater than 1, it suggests that the population increases as you go from one day type to the next. So the points on this line are what we would estimate would happen when you switch from, or we estimate what happened when you switch from a weekend to a weekday. And this is not surprising. We see that in general effort decreases, but now we can explicitly estimate what this parameter is for each of these fisheries. This is what happens when you don't change a day type. So just going from a Monday or a Tuesday or a Wednesday to a Thursday, you can see there's this coefficient is close to 1. So the parameter is we're essentially saying there's no change or very little change in angling effort as you go switch days among the same day type. And when we switch from weekends to weekdays, we see an increase in angling effort, which is kind of what we would expect. We see a couple of days here where this didn't necessarily happen. And that's on the upper section of the upper 2 sections of the Henry's Fork. And if you've ever been there, you might know why. This is kind of the West Yellowstone Railroad Ranch Harriman State Park area. It's a very popular kind of tourist fishery. Over 80% of the anglers that fish there are non-residents. A lot of them are on vacation, so there's not much difference between a Friday and a Saturday. So that's one reason why we maybe didn't see a big change when going from a weekend to a weekday in that fishery. So when we think about angling dynamics, and I showed this figure or this photo in an earlier slide, this is on the Salmon River at the mouth of the Little Salmon River. And if you look upstream, you might see something that looks like this, where there's a few anglers fishing during the peak of the salmon season. But if you turn your head to the left, it looks like this. And there's a lot more anglers fishing below the Little Salmon River than there is the upper part of the Salmon River. And so the models that I previously showed suggest that there's density independence, so that resources are never limiting the number of anglers that can fish in a certain area. But it's possible that that's not the case. In many cases, there may be some capacity that can support a certain number of anglers. And so maybe that exponential growth model isn't necessarily the best model to use. And so the second objective was to develop density-dependent state space models and test some hypotheses regarding what we feel like is influencing carrying capacity. So this is the previous model that I showed for the process model. This is density-independent model. We can just change this model. And now this is just a reformulation of a Ricker model. So now the change in abundance through time depends on the actual size of the population. So it's density dependent. And now we estimate this parameter K, which is either the carrying capacity or the equilibrium population size. So we've taken our density independent model, and now we say that the population depends on how big the population is at any given time. And this is the figure. So this is the estimates that we get for effort from the density dependent model. And it's very similar to what we get from the density independent model. But now we estimate this parameter K. And this shows that the dashed yellow line is the carrying capacity of equilibrium population for the South Fork of the Snake River. And so there could be a couple reasons why carrying capacity exists. And I'm just going to talk about 2 of them. One of them is social reasons. So anglers may have a certain tolerance for fishing next to other anglers, and when that tolerance is higher, you may have an increased carrying capacity compared to some places where it's not as high. The other reason is a lot more kind of logical, and that's just there's space or there's physical reasons. So maybe there's only a certain number of places where people can park or launch their boats, or literally physical places to stand. And so our first hypothesis was that if catch rates are higher, anglers are more likely to tolerate other anglers fishing around them. And the second one was that the amount of physical access to the fishery also influences carrying capacity. And so this is the model that I showed you previously. This is a density dependent model. Similar to the day type model, we just embed a regression model to estimate the factors that we think are affecting carrying capacity. In this case, I'm using X to signify that's the data on catch rate or the access amount. And the A parameter there is just the physical length of the section. So we know that longer sections of river can obviously support more anglers, which influences carrying capacity. So we kind of account for that in this model. And so here's the effect of catch rate coefficient estimate on carrying capacity. And these are on the log scale. So a negative, any number less than 0 suggests that as catch rate increases, carrying capacity decreases, and vice versa. And this was the opposite of the effect that we expected. We expected that as catch rate increased, that we would have a higher capacity to support more anglers, because there would be a higher tolerance for kind of the proximity of other anglers. And in fact, we saw the opposite to no effect. So that hypothesis kind of didn't really work at all. However, the amount of access available to each section did seem to have a pretty large effect. And we just broke these into high and low categories. And this was a low categories if it had less than 0.5, less than 1 access point per half a kilometer, and highs if it had more than that. And those were kind of broken down because all access kind of isn't equal. Some of these places have huge boat launches, other ones just have little turnoffs along the road. But in this case, when we had a lot of access, the carrying capacity was much higher when there wasn't a lot of access. And in fact, it was about 1.8 times higher for areas that had high access than low access. So if you're a manager and you're thinking about ways to kind of improve the capacity to support anglers, in this case, for these fisheries, it seems like providing access is a better management strategy than maybe implementing regulations or doing something with a biota to try to increase angler catch rates. And so what I just showed you was an instantaneous counts, which is kind of how we model it in this case, but we also use a lot of remote traffic counters to estimate effort. And there's some tweaks that we do to the process models and the observation models that allow us to estimate angling effort without doing a lot of on-the-ground work like we do with our kind of on-site counts that we're collecting. So that's kind of one way we've extended these models. Just for simplicity, I talked about angling effort in the paper and in this talk, but we also use state-space models to estimate catch rates, which we then multiply by our effort estimates to estimate total catch. And kind of the same theory applies with our catch rates as did for our effort estimates. And this allows us to estimate the things that influence the rate of change in catch rates. A lot of times this is environmental covariates. So that's kind of our next area of research on this topic. Just so in conclusion, for us, state-space models have been pretty effective tool for creel surveys. I think our estimates are probably more precise than just using design-based estimates. There's a lot of flexibility. You could have whatever process model or observation model you'd like. There's also some benefits that you don't necessarily have to follow a very strict probabilistic design, which oftentimes can be limited just because of staff time or availability or things like that. And it did really change the focus from just estimating effort to focus on the process that generates that generates the effort that we observe. And this is really important from a management strategy perspective, learning why effort is different from one place to the next, and how we might manipulate that. For instance, the access versus catch rates thing was very important for these fisheries, and especially on catch and release trout fisheries. Understanding why effort is changing can be very important. And that's all I have. If I have time for questions, I'll take them. If not, you can email me or put it in the chat.
Sure, we have time for some questions. Yeah, we're going a little bit over time, but I just want to remind everyone that we record these sessions and we're going to distribute the recording after the webinar is done. So if you need to cut out and we go a little bit over 12:30, just know that you can see that recording. But yeah, if anyone has any questions for Josh, we'll open the floor. Thanks for that presentation. That was really insightful, and it really with Bayesian statistics, it's not an easy thing to understand, but you really put it in a simplified context, and I really appreciate that. That was really great, Josh.
Thanks, I appreciate that. I should mention that the code for this for these models is in the supplements in transactions. So if you're interested in kind of getting into the nuts and bolts of it, you can kind of look that up and change it and do whatever you need to do with it if you want.
Is that on a GitHub?
It's just it's just in text files. If you go to the AFS webpage, you can it's all linked there in the supplemental information for the paper.
Awesome. I'm definitely going to check that out. Looks like Eric has his hand raised. Eric?
Yeah, thanks. Josh, I was just wondering if you could give any more information on those counters, those traffics counters that you're using, cost and how they work.
Yeah, so I can't remember the cost off the top of my head. They're not super cost prohibitive. So we just usually put them in a PVC pipe and bury them next to access points to our fishery. And you kind of there's some tweaking of the settings that you got to use for them. But kind of once you figure it out, it's not super complicated. It just goes changing the batteries every few months and kind of downloading the data. But yeah, we're kind of still working on to figure out exactly the best way to do that. But yeah, they're from the Traffics company, and yeah, they work great for us.
Are they taking pictures? What are they?
No, so they I think they have like a magnet or something that can pick up when metal goes by it. So you just bury them in the ground, or you can put them on a post or something. And then every time a car goes by, it'll just record a hit on the car counter. And so when you get the data, there's different ways you can aggregate it, but it can just tell you like what time it got a hit on the car counter. So yeah, they don't take up a lot of space. You don't have to put anything across the road. They just pick up the metal as it goes by and records it.
Okay, thanks.
Yep.
All right, great. Thanks a lot, Josh. And yeah, if anybody has any follow-up questions for Josh, feel free to throw them in the chat. And I'm going to share my screen now. Can I get a thumbs up from somebody that y'all can see this?
Yep, I can see it.
All right, good deal. Well, I'm Dave Smith. I am the co-chair of the Angler Survey Committee, but also I'm a PhD student at LSU, and my dissertation work is all surrounded around working to innovate and optimize creel survey design and estimation. But this project here is actually one that I started while I was a biologist with Texas Parks and Wildlife, and I've continued to work to put this manuscript out and submit this research with other TPWD biologists, as well as Mike Allen at University of Florida. So before I jump into my talk, I'd like to make a few acknowledgments. There's been several colleagues at LSU that have really helped shape this research as we've finalized the models, but I want to give a shout out to Matt Zink. He really helped put my model together and really provided a lot of insight on the age-structured model building. There's been too many biologists and technicians at Texas Parks and Wildlife to list that have collected data and been a part of designing the research objectives of this project, but listed here are some of the scientists that really had a hand in shaping this project. And the funding source for a lot of the creel surveys, for the majority of the creel surveys run on this project, came from sport fish restoration funds. So understanding how angling sonar has evolved over time can give us a glimpse at just how far the technology has come recently, going all the way back to the beginning of angling sonar in 1957 with devices known as flashers. These were a dial of flashing lights that anglers could look at and tell what was underneath their boat. In the early 70s, the next innovation angling sonar came along with paper graphs, which were devices that needed to be continuously fed with carbon paper, and a stylus drew bottom contours on these graphs. In the mid 80s, digital display screens finally came on the scene, but as you can see here, the resolution in these early devices was really poor. In fact, paper graphs were preferred over those early digital display screens for a long time. But when we look at what anglers are looking at today, the early devices really pale in comparison when we're thinking about downscan and side scan sonar, which was introduced in the late 2000s. With this, anglers could get extremely accurate views of what underwater environments look like at a level that wasn't available with previous iterations of angling sonar. And that leads us to the most recent innovations with live imaging sonar. You're probably familiar with Garmin LiveScope, which was effectively introduced to the market in 2018. Now there's several other competitors on the market, including Active Target and I think there's definitely a few live imaging sonar devices in the market, but Garmin LiveScope is the most popular. And with live imaging sonar, anglers have the ability to pinpoint individual fish locations and watch as that fish reacts to the presence of bait or lures in ways that you couldn't do previously with scanning sonar or any of these other iterations of angling sonar. At least not with the level of precision you can with a live imaging sonar. And as catch and harvest efficiencies presumptively improved with live imaging sonar, we've seen angler concerns voiced by news sources in Tennessee, in Kansas, and even in my former home state of Texas. And if you do a simple browser search of LiveScope concerns, it's definitely going to take you down a deep rabbit hole, but you don't have to search very hard to find anglers voicing their concerns surrounding live imaging sonar, particularly when it comes to crappie fisheries. Now, with the context that anglers were concerned about the impact of live imaging sonar, we wanted to conduct a baseline evaluation, see what live imaging sonar currently looks like on reservoirs, on some of the more popular crappie reservoirs in Texas. With that, we added a live imaging sonar question to our creel surveys. We conducted creel surveys on 3 major crappie fisheries. That includes Lake Fork, Lake of the Pines, and Sam Rayburn Reservoir. And during those creel surveys, we asked traditional questions to produce estimates of effort, catch, and harvest. But we also asked, did you use live imaging sonar during your fishing trip? And that allowed us to subset into live imaging sonar users and live imaging sonar non-users, which includes anglers that didn't use any electronics during their fishing trip, or anglers that used more traditional angling sonar or downscan or side scan sonar without the use of live imaging sonar. So shown here is our directed crappie effort estimates for each of the lakes, as well as an aggregate average. And we saw live imaging sonar utilization either reaching or exceeding a majority of directed crappie effort on each of these reservoirs, with users shown in blue here and non-users effort shown in purple here. It's ultimately led to an aggregate average of 57%. 57% of the effort we observed on these 3 reservoirs came from live imaging sonar users. We also wanted to look at what catch efficiencies looked like between the 2 groups. We compared catch per hour and harvest per hour, and we saw catch rates improved in efficiency by 24%, when comparing users to non-users, but more importantly, when we think about effects on ultimately on fishing mortality, we saw an even higher increase in harvest rate, with harvest efficiency increasing by 31% when comparing users and non-users. Ultimately, we want to do a side-by-side comparison of users and non-users. So we took those harvest rates and multiplied it by an equal scaling factor to ultimately give us a proportional harvest when comparing users and non-users. We then used this estimate later on in our age-structured models when we assessed what potential effects on exploitation might look like. So the results of our creel survey show that crappie anglers in Texas frequently utilize live imaging sonar, and the anglers that are using live imaging sonar are harvesting crappie at significantly higher rates than the non-users. We want to take things one step further and estimate population level effects relative to this increased crappie harvest, and the way we did that through simulating an age-structured model with potential exploitation rates, which we derived from the harvest differences between users and non-users. So ideally, we would have known what fishing mortality looked like before the implementation of live imaging sonar. Unfortunately, that data is not available. So we based our initial estimates of fishing mortality on 3 surrogate levels, roughly based on a meta-analysis conducted by Allen and Miranda that combined 18 different crappie exploitation studies, and we ranged it from low to 20% to high fishing mortality of 50%. Now that sounds really high, but crappie fisheries are extremely harvest oriented, and the mean from that meta-analysis was a fishing mortality of 48%. So we've seen evidence of fishing mortality estimates reaching, for crappie fisheries, reaching a lot higher than 50%, which puts these in perspective as conservative measures of fishing mortality. We then estimated what inflated mortality might look like using those different harvest rates, and this has the potential to increase fishing mortality from 3% at the low end to 7% at the high end. We then built our age-structured model following a traditional stock assessment approach, where in year 1, you have your unfished population, where you start with a scaling factor. For us, we used 10,000 fish. It's an arbitrary number, but this the number of fish in each subsequent age class declines by a constant rate of natural mortality. In the next years, we start to plug in fishing mortality. So now fish are taken out of each age class, both by natural mortality and fishing mortality. We simulated recruitment in the number of age 1 crappie following a log normal distribution with a mean of 0 and a coefficient variation of 0.8 to mimic the really high recruitment variability we typically see in crappie fisheries. We then can plug in growth and maturity estimates to give us our estimate of the total eggs produced by a population in a given year, or a measure of fecundity. We can then take the measure of fecundity in a given year, divided by what fecundity would be in the unfished virgin population, and that gives us a reference point for overfishing and spawning potential ratio, or SPR, which is really commonly used in stock assessment. So shown here are simulations. They're violin plots representing the 10,000 simulations under each exploitation scenario, with the violin plots to the left showing non-user exploitation. This is the exploitation that we estimated before the implementation of live imaging sonar. And then Next to it, we show the response to inflated exploitation. This is what we hypothetically estimated exploitation might increase relative to the use of live imaging sonar. And we did this for fast-growing crappie populations, which we typically see in Texas. We also did this for moderately growing crappie populations, which might be more reflective of general crappie populations across the US. We set our reference point for recruitment overfishing at an SPR of 30%. We borrowed this from another age-structured modeling paper surrounding crappie populations in Florida. And as you can see, even at the highest levels of exploitation, we don't have simulations reaching below our estimate of recruitment overfishing. And in fact, we upped exploitation all the way up to 80% to see what the response might look like. And we still had SPR values for both fast growth and moderate growth above our threshold for recruitment overfishing, indicating that the potential for recruitment overfishing within the parameters that we set up for our age structured model, the potential is pretty low. We also wanted to look at yield per recruit to see if we could see any estimates to estimate the potential effects of growth overfishing. And you can see at the highest levels of exploitation, median yield per recruit continues to increase, which shows us that we haven't yet reached the maximum of yield per recruit, which once we start to see estimates of yield per recruit start to decline relative to exploitation, that's when we start to identify growth overfishing. So the potential for growth overfishing was also low, with exploitation up to 57%. This isn't to say that we're not going to see any potential effects on the crappie populations relative to increased fishing mortality. Shown here is the proportion of memorable size crappie, or 12-inch crappie. And you can see that as you increase exploitation, you do see an effect on the population in the proportion of memorable sized fish, which can really affect angler satisfaction. It is important to understand as we think about how populations might change with potential increases in fishing mortality. So the results of our study showed that the overfishing potential for crappie, given the estimates of maturity that we plugged into our stock assessment models, with exploitation up to 80, as high as 80%, we didn't see evidence of recruitment overfishing with SPR levels below 30%, which shows us that crappie are really they're really hardy species with fast growth rates and a very small size at sexual maturity. And to overfish a typical crappie population, it takes a lot more exploitation in the models we ran than the exploitation, the levels that we applied in this model. So to conclude, live imaging sonar users are harvesting crappie at significantly higher rates than the non-users. The overfishing potential in our simulations was low, but it's important to note that this is all relative to a 10-inch minimum length limit, which shows that this is a pretty effective tool at minimizing recruitment and growth overfishing. However, when we run simulations without this 10-inch minimum length limit, it really changes the output of the age-structured model. So it's important to put all these in context of that of that regulation and understand that we're going to observe different things where there might not be a minimum length limit, or there might be a 9-inch or 8-inch minimum length limit. And ultimately, more precise estimates are needed to truly assess the impact of live imaging sonar. We simply observed that users were harvesting more fish than non-users, but we don't know if those users were always harvesting fish at those rates without understanding how their fishing has changed relative to live imaging sonar. And ultimately, we don't know what fishing mortality is at on any of these reservoirs. So to truly understand whether the overfishing potential exists on a fishery, we're really going to have to get precise reservoir specific estimates of exploitation, and that's typically done through tagging studies. That concludes my talk. I appreciate y'all tuning in, and with that, I can take any questions. Got a question from Nick. We're not really sure about the adoption rate. For this live imaging sonar question in Texas Parks and Wildlife is only been added to creel surveys since I think in 2021 is when we started adding that to the creel surveys. So it's hard to tell what the adoption rate is, but it seems with it being introduced in 2018 and a creel survey, those creel surveys were conducted in 2022 and 2023, and we're seeing the majority of crappie anglers using it. The adoption rate, it seems to be pretty high. John, go ahead.
Yeah, thanks, Dave. This is super cool work you guys are doing. Kind of similar to Nick's question. Do you sense that this is kind of a unique rate for this lake and fishery? And is it sort of across all anglers or pretty specific to crappie? Because I'm from Minnesota and we're working on this as well. And we have, based on preliminary takes from the last few years of surveys where we asked, we had a much, much lower use rate, like in the 10 to 12% of most of the ice anglers. But so this is pretty kind of eye-opening for me. Do you think this is representative of other fisheries and systems across Texas?
So we also conducted these creel surveys. We did this study on 10 different reservoirs that we had the TPWD had their traditional creel survey set up on. And the amount of effort that goes into targeting crappie on some of those other Texas reservoirs, it's not as high. Largemouth bass is the primary focus of anglers in Texas. So, but going to those reservoirs that I highlighted, those are reservoirs where we've seen up to 30% of total effort geared towards crappie in historic creel surveys. So I think that our findings are relative to other reservoirs and throughout the Southeast, and I'm not really sure what it looks like in other fisheries, but definitely wherever crappie is a focus, that's where we've seen higher adoption rates. Yeah, Daniel.
I just wanted to make a comment, kind of follow up on that. Like we started asking here in Florida too, and it, just based on our water bodies, we're shallow, not a lot of depth like you have in some of the reservoirs. And even though we do have high crappie effort. We just don't tend to have some of the offshore structure and drop-offs where we just haven't seen the anglers implement this technology as readily because it just doesn't seem to benefit them in some of those scenarios where maybe they're going through a single trough, just trolling small plugs or minnows or what it might be. But we just don't have that offshore habitat. So depending on the system that maybe you're managing and what part of the country you're in, you might see anglers that may utilize this more just based on those systems and the habitat that the crappie might be using. So it like John said, we just haven't seen that high of a percentage of crappie anglers using it, but we think it's likely just due to how they fish here in Florida and not having those big deep drop-offs and offshore habitat available.
Mm-hmm. Yeah, it's definitely system specific. In fact, so what I showed was the aggregate catch rates, but when you look at the variability from reservoir to reservoir, there's actually we saw in Lake Fork, we saw a much larger difference between users and non-users. And then compare that to Sam Rayburn, we actually saw non-significant differences between users and non-users on that lake. But in the aggregate, that's where we observed the significant differences. So just like in any sort of stock assessment, you're doing a simplification of something that's a lot more complex and going to be system specific. But here we're just trying to get an expected average response to increase fishing mortality. Craig, go ahead.
Yeah, hey Dave. Yeah, thanks for the talk, and thanks actually for the whole session on database and everything. So very useful. I put a question in the chat, but I thought I'd just kind of bring it up. Do you have any insight on how this technology is being used to target individual fish? And I'm thinking like alligator gar, maybe catfish. I've heard in Oklahoma down, snagging paddlefish that they're actually targeting individuals just swimming around the lake to find. So not sure if you're aware of that with any other kind of larger fish like say alligator gar or catfish.
Yeah, so I think that there's probably 3 or 4 papers in this study that I just don't have time to analyze all the data, but we got it with every species that was targeted, and so we have live scope data for bass, for catfish, for all those species. In Texas, the bass anglers and the crappie anglers are the ones using live imaging sonar. Bass anglers have adopted it at rates that are not as high as the crappie anglers, but still pretty high. On some reservoirs, it's over a majority of it. Bass anglers are using the technology, and I think some folks at Texas Parks and Wildlife are really interested at looking at some of those responses as well. But with crappie, we saw increased harvest rates that might potentially affect the fishery related to that. And we didn't see those increased harvest rates with those other species. So all that to say is there's still a lot to unpack and go through with this data. And I think that there are some interesting questions like that, especially with gar and paddlefish and catfish. And as far as catfish go, I'd point you to the Ben Neely paper that was recently published, where they've done a similar approach with both crappie and blue cat. I think it was blue catfish with live imaging sonar. So there's definitely a lot more interesting research questions to unpack here. But yeah, I appreciate everyone tuning in, and I'm gonna transition really quick. Just give y'all an update on what we're looking for in the future with the Angler Survey Committee. And if this is your first time joining us and you want to continue to connect with our working group, you can scan that QR code and it'll take you to a short form to join the distribution list. So with that, I want to talk about some of the deliverables we're going to look towards building with each subcommittee. In survey design and estimation, we're currently conducting an evaluation of North American creel programs, and I've contacted some of the folks on this call to set up those interviews, and I just wanted to invite others if you're interested in participating in this interview. We're interviewing creel programs across North America and trying to find some commonalities between survey design and estimation across agencies. And as we go into the coming weeks, I'm trying to schedule some more of these interviews as an effort within that subcommittee. The Human Dimension Subcommittee, where there's several authors a part of this committee, and this is an effort that's spearheaded by Rebecca Krogman. We're working on putting together a chapter for 4th edition of Inland Fisheries Management in North America surrounding human dimensions. We really hope that that's going to be a tool that Angler Survey Committee members can use. With emerging technology, we're going to look towards a future webinar. It's going to be focusing on using self-reporting data and try to highlight some talks. That's not going to be the upcoming webinar, but the webinar after that in October, we're going to look to highlight some innovative things going on with self-reporting data. And with the data management subcommittee, you saw today the type of work we're trying to build with each of these subcommittees to build products that can help with creel programs and building and organizing angler survey data management. So we're going to continue to work with this subcommittee to build products similar to today's presentation. And also, as we're conducting that North American creel program evaluation, we're also trying to learn more about the data management process that is conducted by different agencies. So there's definitely a component of that evaluation that is relevant to this subcommittee as well. So our next webinar is going to be mid-July. We're once we nail down 3 talks for this, we're going to get a day and time. But right now, look for mid-July, and we'll send that invitation in your inbox here coming soon. Right now, we have a talk lined up by Caroline Tucker with Ontario Ministry of Natural Resources and Forestry. And I think this talk is definitely going to have some similarities to the one that Josh gave today. So really looking forward to hearing from them about some of the innovative things they're doing with creel estimation. So with that, I appreciate everyone sticking through. I know we're a little over time here, but I'm looking forward to continuing to connect with y'all in the future. And these are the things that we're working on as a committee, and we hope to continue to build some new connections with y'all looking forward in the future. And thanks everyone for coming, and hopefully I'll see y'all in July. Take care.
Thank you.
Thank you.
Thank you, Dave.